Antarctica holds the record for the lowest temperature ever recorded on Earth, a bone-chilling -89.2 degrees Celsius. The continent is also home to some of the strongest winds on the planet. Catabatic winds, driven by gravity, rush down from the high interior plateau, reaching speeds of over 320 kilometers per hour. Despite being covered in ice and snow, Antarctica is classified as a desert, receiving very little precipitation. Antarctica is a continent locked in a perpetual embrace with the cold. Its vast ice sheets reflect sunlight back into space, amplifying the chilling effect. The average winter temperature in the interior hovers around -76 degrees Fahrenheit. Even during the warmer summer months, temperatures rarely rise above -18 degrees Fahrenheit. The coastal regions experience slightly milder temperatures, influenced by the surrounding ocean. On July 21, 1983, scientists at Vostok Station recorded a temperature of -128.6 degrees Fahrenheit. This record-breaking chill was a testament to the extreme conditions that can grip the Antarctic continent. A combination of factors, including clear skies and calm winds, created a perfect storm of cold. News of the record spread quickly, solidifying Vostok Station's place in history. It served as a stark reminder of the unforgiving nature of Antarctica. Antarctica is home to the awe-inspiring catabatic wind. These winds, born from the continent's unique topography, are a force of nature. High above, gravity exerts its pull on the dense, frigid air. This cold air flows downslope, gaining speed and transforming into blinding blizzards. These winds can reach astonishing speeds, exceeding 200 kilometers per hour. Catabatic winds create an unseen landscape of their own. They carve channels through the snow, leaving behind sculpted formations known as sastrugi. These winds can strike with little warning, transforming a clear day into a blinding whiteout. Navigation becomes nearly impossible as landmarks disappear in the swirling snow. Understanding these winds is essential for comprehending the complex interplay of forces that govern this frozen world. The catabatic winds are master sculptors of the Antarctic landscape. They carve away at the ice, creating intricate patterns and formations. One of the most striking examples is the formation of sastrugi, resembling frozen waves. As the winds sweep across the ice sheet, they pick up loose snow and ice particles. This process, known as wind erosion, can carve deep valleys into the ice. The catabatic winds also help regulate the mass balance of the ice sheet. Antarctica, a continent draped in ice and snow, is classified as a desert. The interior receives an average of less than 2 inches of precipitation per year. The extreme dryness is a result of descending air masses and frigid temperatures. The air is extremely dry, with very low humidity levels. Any moisture that evaporates is quickly locked back into ice crystals. This prevents the formation of significant cloud cover or precipitation. The scarcity of precipitation in Antarctica has profound implications. Plants are virtually absent from the interior, with few species confined to coastal regions. Animals rely on the surrounding ocean as their primary source of water. The dryness also influences the continent's geology, preserving ancient rock formations. The ice sheet acts as a time capsule, preserving layers of snow and ice. Despite the extreme aridity, life persists in Antarctica's frozen desert. Microscopic organisms, known as extremophiles, thrive in these conditions. They inhabit spaces between ice crystals in tiny pockets of water. Some extremophiles, known as psychrophiles, thrive in cold temperatures. The study of these extremophiles provides valuable insights into the limits of life on Earth. Antarctica experiences the polar night, where the sun dips below the horizon for months. The sky transforms into a vast dome of twilight hues. Stars shine with an intensity rarely seen elsewhere. During the polar night, life adapts to the absence of sunlight. Many animals rely on stored fat reserves to survive the long winter months. As the polar night gives way to the austral summer, Antarctica experiences the midnight sun. The sun circles the horizon, bathing the continent in perpetual daylight. The golden light illuminates the icy peaks and snow-covered plains. The midnight sun brings a surge of energy to the Antarctic ecosystem. For scientists, it provides a unique opportunity to work around the clock. Antarctica experiences a peculiar weather phenomenon known as a temperature inversion. The air near the surface is colder than the air above it, trapping a layer of frigid air. Temperature inversions occur due to the continent's high elevation and icy surface. The ice sheet reflects sunlight back into space, preventing the ground from absorbing much heat. This stable configuration creates a phenomenon akin to a lid being placed over a pot of cold water. Antarctica, a continent long locked in a deep freeze, is showing signs of strain as the planet warms, revealing vulnerabilities that were once hidden beneath its icy surface. The icy behemoth, once considered immutable and unchanging, is responding to the changing climate in ways that are both subtle and dramatic, raising concerns about its future and the implications for the rest of the world. For centuries, Antarctica has served as a giant refrigerator, its vast ice sheets reflecting sunlight back into space and helping to regulate global temperatures, maintaining a delicate balance crucial for the planet's climate. But this delicate balance is being disrupted as rising temperatures, driven by human activities, tip the scales towards melting, causing unprecedented changes. Scientists studying Antarctica have observed a disturbing trend. The continent is losing ice mass at an accelerating rate, a phenomenon that has serious global repercussions. Glaciers, once frozen rivers of ice flowing slowly towards the sea, are now surging forward, their pace quickened by meltwater lubricating their base, leading to faster ice loss. The edges of the ice sheet are crumbling as massive chunks break off and drift away as icebergs, a process known as calving, which is becoming more frequent. The Antarctic Peninsula, a mountainous finger of land that juts out towards South America, is experiencing some of the most dramatic warming on the planet, transforming its landscape. Temperatures here have risen by nearly 3 degrees Celsius, or 5.4 degrees Fahrenheit, in the past 50 years, far exceeding the global average and altering the region's climate. This warming has led to the collapse of massive ice shelves, platforms of floating ice that extend from the edge of the continent, reshaping the Antarctic coastline. The collapse of ice shelves, while a natural process, is occurring with increasing frequency and intensity in Antarctica, a clear sign of the profound impact of climate change on our planet. These massive platforms of floating ice, some of them larger than small countries, play a crucial role in buttressing the glaciers that feed them, effectively slowing their flow towards the sea. Imagine an ice shelf as a giant cork holding back a bottle of champagne, preventing the liquid from spilling out. When the cork is removed, the champagne rushes out, uncontrolled and with great force. Similarly, when an ice shelf collapses, the glaciers behind it are free to flow more rapidly into the ocean, significantly contributing to sea level rise. The Larsen Ice Shelf, located on the eastern side of the Antarctic Peninsula, has experienced a series of dramatic and catastrophic collapses in recent decades. In 1995, a significant section of the Larsen A ice shelf disintegrated, followed by the even more dramatic collapse of the Larsen B ice shelf in 2002. These events, captured by satellites and witnessed by scientists, provided stark visual evidence of the devastating impact of climate change on Antarctica. The loss of ice from Antarctica has far-reaching global consequences. As ice melts and flows into the ocean, it contributes to rising sea levels, threatening coastal communities and ecosystems around the world. Furthermore, the melting of ice sheets and glaciers affects ocean currents, weather patterns, and the delicate balance of the global climate system, with potentially dire consequences for all life on Earth. Antarctica, a continent of stark beauty and unparalleled extremes, stands as a testament to the power and fragility of our planet. Its icy plains, towering glaciers, and howling winds have captivated explorers and scientists for centuries, drawing them to this remote corner of the world to unravel its mysteries and secrets. From the bone-chilling cold of Vostok Station to the relentless fury of the catabatic winds, we've explored the forces that shape this extraordinary continent, understanding its unique dynamics. We've delved into its unique weather phenomena, from the ethereal glow of the polar night to the relentless sunshine of the midnight sun, which never sets during summer. And we've witnessed the delicate balance of life that persists even in this most extreme of environments. Antarctica's legacy extends far beyond its icy shores. Its vast ice sheets, holding a record of Earth's climate history dating back hundreds of thousands of years, provide invaluable insights into our planet's past, present, and future. The continent's unique ecosystem, home to a surprising diversity of life, offers a glimpse into the remarkable adaptability of nature, showcasing resilience in the face of adversity. Yet, Antarctica is under threat. The warming climate is leaving its mark on this frozen continent, causing glaciers to retreat, ice shelves to collapse, and sea levels to rise, posing a significant risk to coastal communities worldwide. The consequences of these changes are felt far beyond Antarctica, impacting weather patterns, ocean currents, and the delicate balance of the global climate system, which we all depend on for survival. The fate of Antarctica is inextricably linked to our own. As the planet warms, the decisions we make today will determine the future of this icy continent and its impact on the rest of the world. It is our responsibility as stewards of this planet to protect this fragile and vital part of our world. Scientists play a crucial role in monitoring Antarctica's changing environment, providing the data and insights we need to understand the impacts of climate change and to develop solutions. Their research, conducted in some of the most challenging conditions on Earth, is essential for informing policy decisions and guiding international efforts to address climate change. But it's not just up to scientists. We can all play a role in protecting Antarctica. By reducing our carbon footprint, supporting policies that promote sustainability, and raising awareness about the importance of climate action, we can help to preserve this frozen continent for generations to come. Antarctica, a land of extremes, holds a special place in our collective imagination. It is a symbol of the power and beauty of nature, a reminder of our planet's fragility, and a call to action to protect this precious and irreplaceable part of our world. Let us be the guardians of this frozen world, ensuring that its icy legacy endures for generations to come.